In order to do this, okay, let's look at the information that they give us. It says, given the vertex of a parabola, there it is, and the point, there it is on the line of the parabola, I guess. Write an equation of the parabola in vertex form. Now this problem gives it to us all in words. Some problems give it to us as a picture. They give you an actual graph, and they point out 2 points on there. Hopefully they're pointing to the vertex and one of the points, because that makes it a little easier. Because when you think about, now I call this vertex form, our book calls it standard form. When you think about vertex form, there's only 3 numbers that you need in order to complete this. You need an A, you need an H, and a K. Now because they gave us the vertex, we know the H and the K. That's the H and that's the K. The X is the H and the Y is the K. So it would be A X minus 1 squared plus 2. What's the only variable we're missing?
A.
We need to know what A is. So in order to find A, we're going to use the point that they give us, because this point is X, f of X. I'm using f of X instead of Y because I kind of want you guys to start getting used to it. So that's f and f of X. I'm sorry, X and f of X. So to plug it in, they're both zeros, so you're just going to plug 0 into the f of X. Then we have A, plug 0 into the X minus the 1, square it, add 2. Now we have an equation that only has one variable. I say that because if you only have one variable, you can solve it. So here we go, let's solve it. Let's simplify what's in these parentheses since we can. There's no variables inside here, so we just go 0 minus 1 is negative 1. And then we're going to have to square that. So let me clean it up here. We have negative 1 squared plus the 2. So negative 1 squared, that'll be positive 1. So it's almost like this thing goes away, because this just equals positive 1, and 1 times A is just A. So we subtract the 2 from both sides, so we have negative 2 equals A. Boom, there's our A. So we go back to our function, erase the A, and write in negative 2. That's your function. On the last 6 problems, 65 through 70, they give you 2 X-Intercepts. If they give you 2 X-Intercepts, there's ways to go about this. Let's think about it. So let's do 68. What do you mean, can I use any of them?
The X-Intercepts.
Couldn't you do
Okay, so let's think here. I mean, man, there's so many ways going through my head on how to do this. I'm going to try to pick the way that relates to what we're doing. Let's see, 1, 2, 3, 4. There's a point right there. And then 4 more, that's going to be 8. So we're at 4 and 8. Okay, we can have a parabola that goes through it like this, which would be a positive A, or we can have a parabola that goes through it like this, which would be a negative A. So actually the directions say write one equation for a positive one that opens upward and one that opens downward. So let's do this. You guys remember how to find X-intercepts using the zero property? You guys remember that? It would be like this. If these were my answers, wouldn't I have 0 equals X minus 4? What would my other factor be? X minus 8, right? And so to find our function, I would just have to multiply these out. So you would FOIL it. Because, think backwards. If we were trying to use a zero property to find the X-intercepts, we would factor the polynomial, whatever the polynomial is. I don't know what the polynomial is. We would factor it, and we'd get these 2 factors, and then we'd set each of those equal to 0 to get 4 and 8, right?
Why isn't it plus 1 plus 2?
Because normally you don't... Yeah, you explain that to her. Okay, so when I multiply this out, I get x squared minus 12x plus 32. And then I can name my function as f of x. So here's the positive one. How would I make it negative? You have to go like this. Let's do the negative one. We'll make them g. you'd have to multiply the whole thing by -1. So it would be negative x squared plus 12x minus 32. That's how you would do that one. So there's your two functions for number 68, for problems like number 68. Now for max and min, this is short for maximum, that's short for minimum. We have two different types of parabolas. We have a parabola that goes like this, that opens downward, and we have a parabola that goes like this and opens upward. The one that opens downward has a vertex at the top of the parabola. This would be hk, and then our k would be your maximum. It'd be your max. Conversely, the one that opens upward would have your minimum, because it's at the bottom. This is the minimum. Now, maximums and minimums are not really hard to find, because if you can find the vertex, you found the max and the min. So you just need to know how to find the vertex. Well, anyways, let's get an example here. Earlier we looked at this problem. It says g of x equals x squared plus 8x plus 11. If we wanted to find the vertex of this, we could just complete the square. We could, group those together. Then we have x squared plus 8x, and then our plus blank, which was, we did this earlier. What was it? 16. And then it says plus 11, and then we have to minus the blank. That would be minus 16. Okay, so, and then we simplified it, and we got x plus 4 squared, and then minus 5. So what would the first of all, would this one have a maximum, or would it have a minimum?
Minimum.
This one would have, this g function would have a minimum.
Yes.
And the reason why I know that is because the a right here is positive. It's a positive a. So since that's positive, it's a 1 right here. Because that's positive, I know it opens upward. So what would my minimum be? What would it be right here? What would the minimum be? It would be -5. So your minimum, your min, would equal -5. Now, I've learned it to where the minimum is only referring to the y. But sometimes the problem is referring to the whole point, and so you just write the whole point for the minimum. It's not that big of a deal. It's not a big difference. So, is there a way to do this? Is there a way to find -5 without having to change it into vertex form? In order to come up with the answer to that question, what did we do to this 8 to get the 4? Divided by 2. Is that right? Okay. Well, what is the vertex? It's -4, -5, right?
Yeah.
So we technically need to know. We need to know how to get this -4, because in order to find this -5, if I were to just have some way to find this -4, I could find the -5 just by taking the -4 and plugging it into the x, and I would get -5. I wouldn't need vertex form. So we're going to pretend that we didn't do this vertex form right here. We didn't do this. We went straight from this guy right here down to this guy right here, the -4, so we can get the -5 to find our answer. So what do we do to this 8 to get -4? You guys divide by 2 and negative. So you would say b, -b divided by 2, right? Mm-hmm. That was it. That's how we found the middle x. That's our middle x right there. Our axis of symmetry, I should say. How would this work every single time? Would it work with every parabola that we ever see for the rest of our lives?
Yes.
Let's see. Let's make it all abstract. So this represents every quadratic function out there, right? It's just there's variables in here for the numbers. It represents every quadratic function out there. So how would I find, for this, how would I find the middle x? Well, let's make this into vertex form to see what it looks like. And this is where it gets a little hairy. We're going to take these two and take out the a. So we have x squared plus b over a, because I divided, plus c. And then to complete this square, I have to have a plus blank, so let me write that out. X squared plus b over a x plus blank plus c minus blank. Okay, so what would I have to add to this so that this is a perfect square? I would take this, divide it by 2, right? And dividing by 2 is the same as multiplying by 1/2. So I multiply by 1/2, and I would square it. So divide it by 2 and square it. So it would be b over 2a squared. So I'll write b over 2a squared. And then I would have to subtract something, but I'm not going to worry about this right now, because the reason why I'm not going to worry about it is all I need to know is what number is right there. You know, when I factor this, what number is right here, because that's going to be my middle x. Remember over here how, you know, the plus 4 right there, that gave us our middle x? So all I need to know is this, right there. What is that? So I square root that, I get x plus b over 2a. There you have it, guys. That's how we know the middle x. So we actually have to improve our formula right here. We have to put negative b over 2a. And that formula is given to you guys in Algebra 1. Negative b over 2a to find the middle x. That's how you can find the axis of symmetry. That's how you can find the middle x using that formula.